Thank you all so much for joining. My name is Angie Jones. I am an automation architect at Apply Tools, senior developer advocate, also director of Test Automation University. And today I want to talk about Java, specifically newer versions in Java and how we might be able to utilize those in test automation. So let's go ahead and jump right in. Now, while Java is still the leading programming language, it has gotten a bad rep over the years. So some of the biggest gripes that I've heard are Java is too verbose, meaning we have to write a lot of code to do like the most basic things, that Java was not evolving fast enough. So the releases of Java 7 and 8 and 9 were all 3 years apart, which is almost a lifetime in software development, right? Fortunately, the powers that be heard you loud and clear, and Java has gotten a much needed makeover. And now new versions of the language are being released every 6 months. And with so many new features, it's kind of hard to keep up, especially if you aren't paying attention. So in this talk, I want to demonstrate some of those newer features of Java and how we can take advantage of them in writing our test code. So we're going to look at some automation code for verifying this banking page. So the specific test that we'll go over today is just going to make sure that all of these account numbers here are actually listed. So here's our test code, and let me walk you through it. So here we are logging into the application, and we get a handle to this accounts overview page. And this is where that table of accounts is located. Next, we get a list of the account numbers that are displayed on the page. Then we want to get the expected accounts. So this test data, it can change, it can vary, so we are actually going to make a call to an API as our source of truth to get the expected accounts. And this will return a list of deserialized account objects. So we want to make a new list, which will only contain the account numbers as strings as opposed to the entire account. And we'll loop through the list of account objects and add the account number from each account into our list of expected accounts. And then finally, we compare both lists to make sure that every account for this customer is actually shown on the site. So this test was written in Java 8. We're going to go through it, and we're going to see how we can modernize it using some of the latest features in Java. All right? So let's start here with the declaration of the accounts overview page. As you can see here, we're following Java conventions. We're using good names for both our class and our object. However, many times, as we see here, these two names are actually the same thing. So this becomes redundant, right? And it makes for a lot of typing. This is how Java got the rep for being verbose, right? So in version 10, Java introduced type inference for local variables. So what this means is that instead of explicitly declaring the object or the variable's type, we can instead use this keyword var. And Java will infer what the type is based on what is being assigned to it. So this is my favorite new feature in Java because in automation code, we always have these long class names for our page models, and now we no longer need to type them out. But before you get carried away and start using var everywhere, let me explain to you the rules and also give you some tips here. So this does not make Java a dynamically typed language like JavaScript or Python. That's the first thing that came to my mind when I saw this. Like, oh my goodness, is this not a statically typed language anymore? So I had to do some digging and some research. And I found out that the type is still there, actually. It's just inferred from the right-hand side of the statement, which means you can only use var if you're actually initializing the variable. Otherwise, Java can't infer its type, right? It won't be able to tell what this type is. So this is incorrect. You can't do this. Also, it only works for local variables. So you can use this inside of methods, inside of loops, decision structures, lambda expressions, but you cannot use this for global variables. Even if you are initializing them, you'll get a compilation error. Now, while the local variable type inference can be used within the body of local constructs, it cannot be used in the headers or of methods or constructors. So this is because, think about it, whoever is calling your method or your constructor, they need to know the exact data type of the arguments that they need to send, right? So you cannot use it here. All right. So those are the rules. Now let's get into some guidelines. So not hard rules, but just like good practices. Now, given this variable name and this method name, I have no idea what the inferred data type of X would be as the reader, right? Sure, Java knows because Java knows exactly what this getX method returns. So it's able to infer like, okay, X is going to be this. However, me as the reader, I can't easily tell what this is. So I would need to go to the getX method or look at its signature to be able to determine what X is. So this makes it really difficult to work with this variable, right? If I'm coding along. So you should always be using like good variable names, but it's even more important if you're going to use var. Now, once you start using this, you're going to love it. All right. Take my word for it. But please, please, please don't overdo it. Right? So using var here, for example, this doesn't do you any favors. Clearly, the number 5 is an integer. Just use int, right? That wasn't that hard to type. It's the same number of characters. You don't need to use inference for this, right? So use it where it makes sense. If it's, something simple, just go ahead and type it out. If it's hard to determine based on the statement what the type is, like you should be able to infer a little bit too as the reader, right? If not, then you need to redo some things. So I've updated our test methods our one test method, I've updated the code to use vars. So I'm using a var here, and the inferred type is very clear to me, right? As the reader, because of the variable name that I chose here. This is obvious. This is a accounts overview page. Here, I changed the variable name because it wasn't obvious. So I changed the variable name from actual accounts to actual account IDs list so that it's clear that this is a list and it's holding the account IDs. For this one, similarly, I also changed the name from accounts to accounts list so that it's clear this is a list that's holding account objects. Here I changed the name to be more representative, and I also defined the data type in the array list on the right-hand side. So if I didn't use this diamond operator and explicitly state that this is a list of strings, then what Java would have done is inferred from the right side that, okay, this is a list of some type of object, right? It would have been a list of objects. And in this case, that would have been fine. It still would work. But if you are trying to do, more explicit things, like you're getting each item out of the list and you actually want to do a dot and see the methods available to, like, say, string objects, for example, then you would need to explicitly declare that, yeah, this is an array list of strings. All right. And then here I'm using var inside of a for loop just to show you that it can be done here. Honestly, I'm not sure if I prefer this to be explicitly declared as a count so that it's clear to me as the reader, but you know, it kind of has the same name. So it would be a little bit verbose, like account, a little redundant. So this is fine, but I'm just going to change it back to account in our code just so that we don't have vars everywhere, and I can show you how you can, you know, mix and match. All right. Okay, so let's see what else we can modernize here. How about we go inside of this get accounts method? So let's look at the site again. Remember, this is a table and we're getting all of those values in the first column labeled account. So here's the code to do so. And we can see here that it finds all of the account sales, and these are web elements. Then it creates a new list to hold just the text of the web elements. So this is going to be a list of strings, right? And then to populate that list, we loop through each of the elements from line 3. We get their text, and then we add them to this new list that we defined on line 6. Right? So this works, this is fine, but there's a more modern approach to do this in Java by using a functional programming style. So this approach was actually added in Java 8, but I don't see a lot of people using it in test code. So I wanted to quickly highlight it here. Now, before changing this, our method needed 2 lists and a loop to be able to do what it needed to do, right? So this approach is much more streamlined. So here we still call find elements to get the list of web elements, but we don't need to store them. Instead, we turn them into a string from which we can do some cool functional programming, like this map function. So this will take those web elements and map them into whatever is passed into this function, right? So here we're saying get the text from those web element objects. I just want to pull the text from every one of those. And once you pull the text from every one of them, then go ahead and store them into a list, which we will return. Now here's an alternative way to write the map call. Notice in the top example on line 5, we use a shortcut or a syntactic sugar where I say web element : get text. So this is a shortcut. But on the bottom example on line 3, this is the long way. So basically you would specify some variable name. So this is like E for element, and then an arrow, and then followed by whatever you want to do with the E, right? So both of these do the exact same thing, just an alternative way to write it. And we can do the same thing in our test method as well. So instead of using the 2 list and a for loop, I use a stream and map what I need into a single list. So a little bit more streamlined. All right, let's see what else we can modernize. How about we go inside of this get customer ID method? So this method, hold on. This method is holding our test data, and based on the name on the account, it's returning the account ID. So this is using switch statements, and notice we have to declare the variable, and then we specify each case that we want to handle. And inside of the case, we assign the value to ID. Then we must follow that assignment with a break statement to prevent fall through to the next case, right? Which would override that ID variable. So if we forgot to put the break there and we call this switch using John, then his ID would be 4847474 because it will fall through to Mary's, right? So not only is this like a lot of boilerplate code, but it's also flaky, right? So if you forget one of those break statements, you get the wrong value back. So in Java 12, switch expressions were introduced. So now you can use switch to directly assign a value to a variable. So notice here, we are using switch on the right side of a statement to initialize this variable called ID. The case doesn't need a colon in switch expressions, but instead it uses this arrow. And this is saying if the name is John, then assign 12212 to the variable ID. And notice I don't need a break statement here anymore because there is no fall through with switch expression. So it makes it a bit safer to use. And I can even simplify this a bit more by removing this assignment here and just using a return, just returning the result of that switch expression. So using the lambda style arrows is one way to assign the value, but you can also use another approach within switch expressions. So you can use the colon that we're used to, but you need to follow that with the word yield. So this is a new word added to Java in, I think, like Java 13 maybe. So this is a bit more verbose. So I prefer to just use the arrow myself, but this is an approach. And I'll show you where this approach might come in handy. Now, in this example, since we don't have the fall through, that was one of my first questions when I learned about switch expressions. Sometimes I want it to fall through, right? I have multiple cases that need to get the same value. So if I use switch expression, how do I handle that? Well, you can do so. Notice here, we are saying if the customer is John or the customer is Demo, which is his last name, then the ID is 12212. So this makes up for that removal of the fall through from the switch expressions because you can indicate all of the cases that have this value and just delimit them with a comma. So this much cleaner, much safer. You can also do more than just assign values, right? So here's where we use the lambda style arrow, but we also use the yield word in here. So here, if you need to do more than just assign the value, like you want to do a couple of statements and then finally do the assignment, because switch expressions are for assignments, right? So if you want to do your assignment, but you also want to do some stuff before that, then you would just use the arrow followed by a set of curly braces. And inside of the body or those curly braces of this case, you can add more statements like this one, right? So I'm just printing out, hi, John, or whatever. But the last line of the case must yield a value to be returned. So that's where the yield and the arrow come into play together, okay? All right, let's talk about some rules with switch expressions. You'll need to use the arrows or the colon. You can't use both, right? So line 3 here would give you a compilation error because it's a different kind of case from line 2. You can use the yield with the arrows, like I said before, but only in events like the last case where you're using the curly braces to execute multiple statements within the case. You can use any of the cases to throw an exception. So of course, if you throw an exception, then no value is being returned for ID in this case. Instead, the entire flow is interrupted by the exception. Now, here is a good case where it makes sense to throw the exception because, none of the customers here were given. It was given some name I don't know, so I throw an exception. But it doesn't have to be just the default case. You can do it in any of these cases. So with John or Mary or Tom, any case, you can throw an exception and then you can continue on with values for the other cases as well. That's totally valid. This is not a replacement of the switch statement. It's an addition to the language, meaning you can still use your switch statements. They're not going anywhere. And in some cases, it might be the more favorable option to use. So as a rule of thumb, use expressions when you are using switch to assign a value, and use statements when you're not using switch to assign values, but instead you're just invoking statements. All right. All right. So let's go back to our test. And how about now we look inside of this get accounts method, which is an API call. So this is the method, and it's making a get call to all of the accounts for the specified customer. It's then deserializing the response into an array of account objects. All right. So let's look at the API response for this call. Notice here we have an array of these account objects, and each account has an ID, a customer ID, a type, and a balance. So I have this POJO class. It has nothing but these fields as well as getters and setters. So for any of you who have created POJOs, which are plain old Java objects, meaning they just have some fields and then they have getter and setter methods, if you've done this, you know that it's tedious to do. So many people have moved to using the Lombok external library so that they don't have to write all of this. But in Java 14, which is the version we're on right now, a new construct has been introduced called records. So this is a record, much shorter than the POJO, right? So notice here, instead of using the word class, we use the word record. Also, as opposed to opening this with curly brace, we use parentheses to declare the fields. So you specify the fields and their data types in this comma delimited list. Then you close it with a closing paren and a curly braces, a set of curly braces. And that's it. You don't need to make any getter methods, setter methods. You don't need to override the inherited methods of equals and hash code or toString. All of that is just done for you, and it's done for you beautifully, actually. However, if you just want to override something, you can do so within these curly braces here. So for example, this is overriding the toString method that we inherited from the object class, and just printing this out. Now, without the overrides, it prints out beautifully. It will print like each field name and then its value. So you don't have to override. But in the cases that you need to, those curly braces that go with this, you just inside of here do whatever you want to do. All right. Now, records can be instantiated just like classes. So account is the name of our record. We use the new keyword and we call the constructor passing in all of the values. So you construct this just as you would a normal object. And the fields of a record are final. So there are no set methods generated for records. Of course, you can add a setter within the curly braces of the record, but I don't see a good reason to do that since these fields are final and they cannot be modified anyway. So you do have the accessor methods or the getter methods. However, they don't start with the word get like we're used to. Instead, the accessor method name is the exact same name as the field name. So notice here, we're calling account.balance as opposed to account.getBalance. All right. Now, records were released as a preview feature in Java 14, which was released in March. And what this means is that it's in preview. It's not yet a permanent feature of the language. It's just available for us developers to play around with and offer feedback. And based on that feedback, the implementation of this can change, right? That also means that support from external libraries may not be available just yet. For example, the Jackson library is used to deserialize JSON responses into the record. However, the Jackson library doesn't officially support records yet, right? Because records is still in preview and not a permanent feature. And when I say not a permanent feature, it means it could change, but it could also like be scrapped. Like we could say, okay, this isn't working and we're not going to put records in Java at all. So don't use records in your production code just yet. You should only use it to play around with for right now until it's permanent. All right. So for Jackson, if you want to start playing around with it now as a hack, you'll need to explicitly bind each field to its respective JSON property. So when and if records becomes permanent, I'm sure that the Jackson project will provide support so that explicit binding isn't necessary. I've already seen a couple of tickets on that project, so definitely looks favorable. Okay, next I want to show you text blocks. So let's continue on with this API call. What if instead of calling the API, we wanted to mock the data right here in the API util class? So to represent this whole thing as a string would be very tedious. We'd need to escape all of the fields because they were already in quotation marks, and we need to add new line characters for each line break, plus these plus signs. So this is ugly, right? It's ugly to read, it's ugly to write. Well, text blocks allow you to use 3 quotation marks to open and close a big block of text. So notice you don't need to escape anything. The individual quotation marks are still there on the fields and the line breaks are respected. So text blocks were introduced in Java 13 as a preview feature. And we got a second preview in this latest release of Java 14. So this is also not a permanent feature just yet, but it is slated to become a permanent feature in the next release of Java 15, which is in September. All right. You cannot include the entire text block on the same line. If you're able to do that and it's such a small text, just use your quotation marks, right? But if you try to, let's say it is a big text, but you just had it like spanning the whole line, you're going to get a compilation error if you try to put it all on one line. A new line must be after the opening quotes, like in this second example here. And this is legal how this looks, but it's not the preferred way. It doesn't look great either. Instead, the preferred way is to have both the opening and the closing quotes aligned and the text in the middle, right? So I have on the first line, the opening quotes, all the text I want, and then the last line, the closing quotes. All right, one more thing I want to show you in that API class. Let's say that we didn't want the entire response, but we wanted to just return like a hard-coded list of expected accounts. The old way of doing this would be to use this arrays as list method right here. However, in Java 9, this of method was introduced for all entities in the collection framework. So lists, maps, sets, etc. And this one seems small, but I've actually been enjoying it quite a bit. So I think the reason that I'm really enjoying it is because it's more natural for me. Before it took a bit of cognitive effort to recall like which class do I use to make a quick list. Is it array? Is it arrays, plural? Like what is it? So it would take like a little bit of mental exercise there. But now I want a list, I call list.of. I want a map, I call map.of. So it's nice and straightforward. And speaking of maps, populating these used to require a separate method for each item that we wanted to add to the collection. Now you can define a map all within one line of code. So the parameters are key followed by value. And you can do this as many times as you need, as many entries as you have, right? So see here, we have 3 entries in this one line. It's key value, key value, key value. One thing to note about using the of method is that it creates collections which are immutable. And what this means is that the collection cannot be changed by adding, removing, or sorting it later. So only use the of method when your collection won't require any later changes within that same program. Okay? All right, so those are a few of my favorite new features from recent versions of Java. I've been using them in different projects, and I find them quite useful for our test automation code. So hopefully you'll give it a try as well. Okay, let me see what questions I can answer for you. Okay, let's see. Is Java turning into Visual Basic with type inference? I haven't used Visual Basic since college, so I don't remember like much about it or what type of language it is. I can't answer that. I'm sorry, but I'll just say Java is just being Java. Like anytime I post something about new features, people say like, I don't know, they just compare it with some other language. Like, oh, Java's trying to catch up with Kotlin, or Java is doing this or whatever. We're just trying to, keep the language more modern. And yeah, it might take inspiration from some of the other languages that people are enjoying, but that's good. That's good for the ecosystem.